Our session today, we will look at demand and supply practices. So we are going to dominate on just the principles surrounding that. So to start with, demand curve we know is downsloping, and the demand curve is simply the summation of individual curves. This means that for any given price, when we sum up the quantities for every individual member, we come up with what we call the market demand. So market demand is simply the aggregate of individual demand. So suppose the total market for a product comprises of three individuals. We have individual one, individual two, individual three. And the sum total that we're getting is 50 minus 25p. So we know that demand is what? Downsloping. If an individual has a demand which is like this, another one has a demand which is like this, another one could have a demand which is like this. When you total up, what we get is called the market demand. And generally, market demand is made up of different demand curves. So demand curve is given by Q is equal to what? A minus BP. This is the demand equation. So in this case, we've been given these individual demands, and they're given by the function Q is equal to 50 minus 5p. So the question is, what is the market demand for this product? All right, so if each of these ones here is equal to 50 minus 25p, so we're just simply multiplying by 3 or adding. So 50 minus 25p for consumer 1 plus 50 minus 25p for consumer 2 plus 50 minus 25p. So together, when you add these ones, will give you our aggregate demand, which is 150 minus 25p. So simply multiplying this by 3, 50 times 3 is 150. So 25 by 3 is 75. So this is giving us our aggregate demand. And from our previous class, I explained how to sketch a linear equation. The simplest way to sketching a linear equation is by putting the letters on one side. So 150 minus 75p. What do we do to sketch this? We put the letters on one side. So what are we going to have? When this one crosses over, we're going to have Q plus 75p is equal to 150. So what number is there? There's an invisible one there. So 1 into 150 is 150. And 75 into 150 is 2. So to cut the p-axis at 2 and the q-axis at what? 150. So this is how you draw this horizontal line. So this is how you sketch. I repeat, q is equal to 150 minus 75p. So when this one comes this side, it becomes what? A positive. So where there is no number, we know there's an invisible one. So 1 into 150 is 150, meaning the q-axis to cut where? At 150. Then the p-axis, 75 into 150, it is 2. So we know that p is always on the horizontal, q is always on the, so you put a 2 there, and you put a 150 there, and you sketch. Are we together so far? So this is how we sum up the three individual demands. Question number 2. Suppose that the total market for a product consists of demands of individuals 1 and 2, and the demands for the two individuals are given as follows: 20 minus 2p and 40 minus 5p. So what is the equation of the market demand? Okay, like explained, we are what? Summing up these two. Q1 plus Q2 is simply Q, market demand. 40 plus 20 is simply what? 60. Minus 2 minus 5 is minus what? 7p. So this is our market demand. Now, how then can we sketch this? How do we sketch this? We put the letters on one side. What are we going to have? Q plus what? Plus 7p is equal to 60. There's an invisible one here. So where will it cut the p-axis? We divide what? 60 divided by 7. We get 8.57. So here to cut at 8.57. Then 1 into 60 is 60. So this is our demand equation. The demand equation of what? Q is equal to what? 60 minus 7p. All right. So this is how we aggregate that all together without much ado. So this is how we sketch that. So that is how the aggregate demand is. So we're just simply revising what we were looking at. So question number 3, consider the demand function is 25 minus 3p, where Q represents the quantity demanded and P represents the price. Calculate the elasticity when price is equal to 4 and when price 2 is equal to 3. So one thing we must understand is that price elasticity of demand measures the responsiveness of demand due to changes in prices. So elasticity measures how you and I react when there are changes in prices. So the formula for elasticity of demand is simply given by Q is equal to A minus BP. This is the demand function. So to calculate elasticity, we want point elasticity of demand and arc elasticity of demand. So point elasticity of demand is simply B times price over quantity. Now, elasticity of demand is at 3 points. There's what we call unit elastic demand, and there's what we call elastic demand, and there's what we call inelastic demand. So we have 3 regions that I like to show. There's 0 here, there's -1, and then -2. Any number between 0 and -1 is called inelastic. So at point A, we are inelastic. At point B, we're exactly 1. This is unit elastic. And at point C, we are more than 1, which is elastic. So any number starting with 0 point something is inelastic. Any number starting with more than 1, it's elastic. Then elasticity of demand is always supposed to be negative. So you need to tell me which of these ones here are unit, which one of these ones are inelastic, and which one of these ones are elastic. So what is A? What is A? -1. What comment do you have on A?
It's elastic.
It's Elastic.
Yes.
B. What is B?
It's elastic.
Inelastic.
It's elastic. Elastic, yes.
And C?
C is inelastic because it's between 0 and 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 is that -1 or 11?
It is negative 0.11.
Okay, so it's inelastic.
And D? So A is unit elastic because it's exactly at 1. B is elastic because it is what? It is
After 1,
after.
after -1.
Then C is 0.11 because it's what?
It's
It's
between 0
0
and
point something. Then D is not demand elastic.
Sorry, I just want clarity. On A, is that -1 or just 1?
It's -1.
So -1 is unit elastic, you said?
Yes, exactly 1 it is unit elastic.
Okay.
Is that clear?
Yes, it's clear.
All right. So let's try again. -4, negative 0.4, negative 1. So B, C, D. Which one is elastic? Which one is inelastic? And which one is unit elastic?
D is unit elastic.
Which one is unit elastic?
D.
D. Uh-huh.
Yeah.
And B?
Then uh, then B is elastic. Then C is non-elastic.
B is elastic, C is inelastic, and D is
Yes.
unit elastic. Correct.
Yes.
Do we all agree?
For me, I'm a bit behind
A bit behind. So
on the
demand
same
at T.
explanation.
If it is
Mm,
between 0 and 1, as long as I am at 0 point something, it is inelastic because it's below 1. So 0.9, 0.8, negative 0. To start with, demand elasticity is negative.
mm,
Okay? Your summer
okay.
demand elasticity are supposed to be negative because demand has a negative relationship. How do you get it? So your
Yes.
will be negative. But between 1, -1 and 0, anything starting with 0 point anything, negative 0 point something,
Mm,
is inelastic. Okay? Sharp
okay.
one. If it's 1 point anything, 2 point anything, 3 point anything, 11 point anything, it's elastic because it's more than 1, greater than 1.
Okay.
But exactly 1,
All right.
it is unit elastic. Fine.
Yes.
Now, Africa, is that clear?
Thank you. Yes.
All right. So with that being said, there are only two formulas we're going to dominate on. Elasticity of demand when you're dealing with the direct demand function is given by B times price over quantity. When do we use this formula? When we have Q as substitute formula. This one is the easiest. So if your Q is equal to 10 minus 2P, so our B is a gradient. The B is simply the number that comes before the letter. Here our B is -2, -2. Then suppose we're given our P as 4. Katwabika 4. What will be? This will be 8, right? So 10 minus 8, the answer for Q will be what? 2. So we substitute just in here. Up at the B, what do we put? Are we together? Any questions?
Just come again on the B. You said that if it's in any letter that is in front of
Hello, we can't get you. I don't know if I'm the only one. I think you're muted.
Okay, so if you're given a function like this one, it's called a direct demand function. So murithi, we are only given the P, that know that price is what? 4 kwacha. So ngatuandika 4 kwacha here to be 2 times 4 is 8. 10 minus 8 is 2. That's how we calculated this. Then the B, you can identify it. Then letter that comes before the number that comes before the letter, -2. If there was -3 here, our slope would be -3. So using this formula, upper the B will put -2. The price is 4. The quantity is 2. So when you multiply this by that is 8. This by that is 2. So what is our elasticity of demand here? -4. What is your comment? Is it elastic or inelastic?
Inelastic, brother.
Are you sure?
elastic.
It's elastic, yes. It's more than 1. All right? It's elastic. Please don't make a mistake. Starting with 0 point something, that's when it is inelastic. Let's try another one. Suppose Q is equal to 50 minus 4P. And we're given our P as 10. Help me find two things, the B and the Q. If our P is 10, what is our Q and what is our B?
B will be 8. Is it? Yeah, 8.
This equation, what is your B? Here our B was what? -2. Who sent the pay in parity P to ascend the -2? So B should be the easiest to identify. Where's the 8 coming
Okay, the
from?
one in front of the. Okay. That's clear.
So B, what is our B here?
-4.
Yes.
-4.
-4. And what is our Q?
Q is equal to 10.
When you put 10 there, 50 minus 40 is 10. So Q is equal to 10. Are we all agreed? So Q was calculated. So we're looking at demand and supply, elasticity specifically. Then we substitute in this formula. Elasticity of demand, what do? We substitute in this formula. So B price times quantity. What is our B? -4.
-4. Yeah.
Our price, 10.
Yeah.
Quantity, 10.
Yeah.
When we calculate, we're going to get our elasticity as 4 negative as well. What is the comment?
Elastic.
Is elastic.
Yeah.
Sometimes they'll give you the elasticity in terms of price. Price is equal to 10 minus 2Q. So the formula will change here because now this is called an inverse demand. The only difference is just 1 over B. The rest is the same. 1 over B, price times quantity. In this case, suppose we're given our Q as 3 what becomes our P? When we put a 3 there, it will be 6. So 10 minus 6, we get a 4. Then what is our B? The number that comes before the letter, which is -2. So we substitute now. In here, what do we put on the B? 1 over -2. And what we put on the P? The P we're given already as what? We calculated already as what? 4. Times 4 over 3. So we're going to have 4 over 6. What is 4 over 6? 0. What? So that's 2 over 3, 0.67 negative. What do we have as a comment here for elasticity? Is it elastic or inelastic or unitary?
It's inelastic.
Yes, it's inelastic.
So in this scenario, they'll probably give us the Q already as a 3, right?
Yes, I'll give you
Okay.
the Q as a 3.
Okay.
So this is called the inverse demand. When P is subject to formula, the Q looks like this. Elasticity of demand formula is an inverse. Okay, let's try together again. Another one. P is equal to 50 minus 4Q. And we're given here as our Q is equal to 5. What is our P and what is our B? And what formula do we use? What is our P? When you put a 5 there, it's 4. That is 20. So what becomes
That's
our
30.
50 minus 20 is 30. And what is our B?
Our B is 4, -4.
-4. So which formula do we use? This formula.
Yeah, that one.
Yes.
Yeah.
B.
So elasticity of demand is equal to 1 over B. All right? So -4 there. Our price is what? 30.
Price is 30. Yeah,
Quantity is what?
5.
5. So this will be 30 over 20, which is 1.5 negative. What is your comment?
1.5, it's inelastic. It's 1 point, it's above 1, so that inelastic.
Inelastic or elastic?
Inelastic.
Are you sure?
It's negative 1.5. It's above 1.
It's above 1.
It's above negative. It's above -1.
So is it elastic or
Oh,
inelastic?
it's elastic. Sorry. It's elastic. Sorry.
Elastic. So inelastic
Yes.
is anything starting with a 0 point something.
It's a 0. Sorry. Yes.
So this is when we're using the formula. So elasticity of demand is simply the percentage change in what? Percentage change in quantity over percentage change in what? Price. So percentage change, we put a triangle like this. Change in quantity over percentage change in price. The elasticity of demand is always negative. So suppose we're told that the price of fuel has increased from P1, which is 10 kwacha, to P2, which is 15 kwacha, causing a quantity demanded to also decline from Q1, which is 100 units, to Q2, and they've reduced by what? To 60 units. Calculate the elasticity of demand. Okay, so percentage change means Q2 minus Q1 minus Q1 over Q1 times 100. That's a percent change in quantity. And the percentage change in price will be what? P2 minus P1 over P1. That's the percentage. So what is our Q2? What is our Q2?
Q2 is 60
60 minus what?
minus 100
Over
over 100.
what do we get? Times 100%. That is giving us negative 40%. Okay. Then on top, below the P2 is what?
It's 15
15 minus what?
minus 10
Over what?
over 10
Times what?
times 100.
What are you getting?
50.
50%. On top is 40%, below is 50%. So percent and percent will cancel. 40 divided by 50, what do we get?
At negative 0.8.
So what is your comment on negative 0.8? Demand is what?
It's inelastic.
Elastic.
Inelastic.
Mhm.
So in practical terms, what does inelastic mean? Insensitive. All right. For instance, I usually give an example of a nail cutter. We don't buy it on a daily basis. So whether it's 5 kwacha or 10 kwacha, you still buy because you are insensitive to it. But fuel, tomato that we buy daily, we are sensitive. We will react. We will go to our close substitutes. That's what it means to be elastic. So it's important in pricing decisions, in policy making decisions, that you are sensitive to prices. All right. There are, however, times when we would want to calculate what is called arc price elasticity, so that we know the range within which to not make prices fluctuate anyhow. So, for instance, given our quantity is 10 minus 2p, then you are told that your P1 increased from 2 kwacha to P2, which is 3 kwacha. Or let me put 4 kwacha. What is the arc price elasticity? So first you need to calculate the Q1 at 2 kwacha and Q2 at 4 kwacha. So when you put a 2 there, that is 10 minus 4. What do we get? 6, right?
Mhm.
Put a 2 there. 10 minus 4 is 6. How about when you put a 4 there? What is our Q2?
Plus 8 plus
10 minus
2.
8, which is what? 2.
2.
So arc price elasticity, therefore, is simply the change. So it is Q1, Q2, Q2 minus Q1 over the average Q2 plus Q1 divided by 2. Divided by the same P2 minus P1 over the average P2 plus P1 divided by 2. So in this case, we calculate. So Q2 minus Q1, that is 2 minus 4, 2 minus 6 over 2 plus 6 divided by 2. That is 8 divided by 2, which is 4. Divided by P2 minus P1, so 4 minus 2 divided by the average of this one. 4 plus 2 is 6. 6 divided by 2 is what? 3. So this is Negative 4/4 is what? Negative 4/4 is 1. Negative. Divided by, what is 4 minus 2? Is 2. 2/3 is 0.6. So 1/0.6, what do we get?
We get negative 1.5.
Negative 1.5. And what is your comment?
It's elastic.
It is what?
Elastic.
Elastic. Correct. So demand is elastic. So now, can you fail to answer this question? If a given demand function and P is given by 4 quarter and 3/4, calculate the point elasticity and state whether it is elastic or inelastic. And also we're being asked to calculate arc price elasticity and also to comment on these prices, the relationship. So I will require you to answer this question as your homework. I'll need this work today. I'll send it to the groups. That is your homework. Okay. So homework. So just to explain a few things here, you must understand that there's a relationship that exists between price, this application that we have for elasticity of demand. So this relationship is very important because it helps us for pricing decisions. So we know elasticity measures the responsiveness of demand to changes in price. So when elasticity is at total revenue maximizing point, we usually get -1, which proves that total revenue is maximized when demand is uniform. Okay. So whenever total revenue is maximized, the elasticity is usually -1. So the relationship that exists with total revenue is that as price goes down, the region becomes inelastic. So what actually happens is this: in a normal state, elasticity of demand, total revenue is maximized when this is a normal total revenue function. The maximum point here, this is the total revenue. Okay, so the relationship here is that at this point, so our total revenue, so average revenue. So marginal revenue, average revenues here, marginal revenues here. I'll talk about the graphs properly later, but we must understand that when we are looking at the total revenue, when total revenue is maximized at this point, marginal revenue is 0. So elasticity is at its highest. That is that elasticity is equal to 1. As you decrease here, demand is inelastic. As you increase your prices, demand is elastic. So this is the relationship I wanted you to know. You should read about it as well. So elasticity is a very important component in economics because it helps us understand the relationships that exist between our prices and quantity demanded. So we end here. I have sent you the homework already. Thank you so much for your time. I'll share the video.
We share